Hello and welcome to the channel. If you are new, please drop a like, comment, subscribe if you haven't already. You know what to do, and without further ado, let's get into the topic of today's video, which is going to be exponents. So, first thing I'd like to discuss is the exponent laws you guys should know for grade 10. So, first let's go over a times n times a to the power m is equal to a n plus m. So all this basically says is that if you have a base raised to an exponent multiplied by that same base raised to an exponent, you can add the exponents. One very similar to that is if I have something like a to the power n over a to the power m, I can rewrite it as a n minus m. Very similar to the one above, same base law still applies. If I have the same base, divide, I can subtract their exponents. Next one, say you have something like a n to the power m is equal to a n times m. So if I have an exponent or base raised to an exponent in brackets raised to an exponent, I can multiply these two exponents. Another one, if I have a multiplied by t raised to the power of something, that power distributes to both of the values inside the bracket. One that's probably pretty new to you guys is if I have a negative exponent, a to the negative n, I can go and rewrite it as 1 over a to the power of n. Just the same as if I had 1 over a to the negative n, I can go and rewrite it as a to the power n. Last one, and in my opinion, one that you guys most commonly forget, anything to the power 0 is equal to 1. So these are the basic exponent laws that you have to know. Unfortunately, I don't have any neat tricks for you guys to remember them. They are what they are, and you just have to remember them. So let's look at a few examples. So say we are given a problem like this. How would we go about solving? Well, what we could do is raise that to the power 3, but then we'd have to raise this to the power 3, right? If that happens, these two 3's cancel out, and I'm left with x is equal to 8. Pretty simple. Again, that same equation law kind of applies, that what I do on the one side, I have to do on the other side. 2. Say I am given a problem, or you're given a problem that looks like this. How would I go about solving this problem? Now, this is a new type of problem I doubt that you guys have encountered yet in mathematics. So let's go and sort of see how we can go about solving this problem. Well, the first thing you can do is prime factorization. So there's nothing that I can prime factorize here. So 5 is a prime value, in other words. This can become 3 squared, and this can become 3 times 5. So what I would have is 5, 2x minus 1 multiplied by 3 squared x minus 2 over 3 times 5, 2x minus 3. Now, what you can do from here is simplify. So how would I do that? 5 times 2x minus 1 times this 2 can multiply with the x and the negative 2. So it would be 3, 2x minus 4. And if we look at this law, right, we can apply it here. So that becomes 3, 2x minus 3 multiplied by 5, 2x minus 3, right? And then we're going to apply this law. So let's go and look at 5 first. So 5, 2x minus 1 minus 2x minus 3 times 3, 2x minus 4 minus 2x minus 3. And then again, I simply just go and I simplify. The negative will go into that, so essentially we'll get rid of the x's, and then negative 1 plus 3 is 2, right? So what we would have is, well, let me just go and write it out. 5, 2x minus 1 minus 2x plus 3 multiplied by 3, 2x minus 4 minus 2x plus 3. So in both of these two cases, the 2x and the 2x cancels out, 2x and the 2x cancels out because a positive and a negative. Then negative 1 plus 3 is 2, so I'd have 5 squared multiplied by negative 4 plus 3 is negative 1, so I'd have 3 to the power of negative 1. This I can then rewrite as 25 times 1 over 3, which is simply 25 over 3. So let's go look at another example, which is actually, in my opinion, a bit simpler. I just want to reiterate something with this problem. This looks challenging, but I promise you it's not. The only thing that is challenging here is knowing which law to apply. So study your exponent laws, evaluate the problem you are given carefully, and then solve it. With these types of problems in particular, prime factorization is very important. So you have to know that you can simplify 9 and you can simplify 15 or whatever you're given. So I'll do another example like this, but let's just look at this example first. So say we're given something like 3 Now, this looks very easy, but I promise you, you can make a mistake with this very, very easily. First thing you should do is not worry about this exponent as of yet, right? What you first should do is focus on solving what's inside the bracket. What I first would do is go and rewrite this as 1 over 3 plus 1 over 2 to the negative 1. And then I would go and solve this, which would give me, that would be 2 plus 3 is 5. So I'd have 5 over 6 to the power of negative 1, which would give me 6 over 5. Alright, because it's the reciprocal. And that's probably another point. When you have a fraction to the power of a negative, or let's say in this case like it is negative 1, then it's basically just the reciprocal of that fraction. And that's it. Like I said, there's nothing special about it at all. So let's look at another example. So say for example we are given something like this. 5x plus 5x minus 4 is equal to 626. Now this is actually quite a challenging problem, because what you'd first have to realize is that the 5x here, or 5 to the power x here, these can actually factor out. Because what I can do is I can go and write it as 5x plus 5 to the power x times 5 to the power of negative 4 is equal to 626. And then I can factor out the 5x. So if I factor out the 5x, I'm left with 1 plus 1 over 625, which is equal to 626. I can simplify what's inside the brackets. So 5 to the power x, this would become 626 over 625 is equal to 626. Now if I want to get rid of this, I'd have to multiply with 625 over 626. So if I do that on both sides, right, if I multiply with 625 over 626, which is the reciprocal, 625 over 626, and this cancels out with this, and these cancel out. So then I'm left with 5x is equal to 625. And that tells me that x is equal to 4, because 625 is equal to 5 to the power of 4. This can be quite a tricky problem. It's something that can catch you out pretty easily. Quite a thorn in the flesh. But just be careful for problems like these. Again, you have to evaluate your problem very, very carefully when looking at problems like this, especially when you're working with exponents. So let's look at the last example. 2 to the power 3n plus 2 times 8n minus 3 over 4 to the power 3n minus 2. So again, it's very similar to the one we already did. Again, what do we have to do? We have to simplify these values or get them something to something that we can work with. So again, this would become 3n plus 2 multiplied by 2 to the power of 3 n minus 3 over 2 squared 3n minus 2. Then I can go ahead and simplify. So 3n plus 2 multiplied by 2 to the power 3n minus 9 over 2 to the power 6n minus 4. Now I can go and simplify. So I can simplify the top first, but I can actually just go and do it all in one step. So all I really have to do is just remember that this would just be minus. So this would become 3n plus 2 plus 3n minus 9 minus 6n minus 4. And then I go ahead and I simplify this. So 3n plus 3n is 6n, right? Which means that this essentially will cancel out. These two will cancel out with this. The minus will multiply in, which will give me a positive 4. So 2 plus 4 is 6, minus 9 is negative 3. Then I have 2 to the power of negative 3, which is equal to 1 over 8. And that is it for this video. Really hope you guys found it useful, found it educational, and that you guys actually learned something from this. If you like the video, please drop a like, comment, subscribe if you haven't already. Then you know what to do. And yeah, that is it for this video.